Hello, everyone. I'm Barb Haake, and I just want to welcome you to Water is Everyone's Business. We have done this before, and now we're going to get back together again, and I have a guest here that you've seen before on Water is Everyone's Business, Peter Sorensen. And Peter, you are the Department of Fisheries, Wildlife, and Conservation Biology professor. Can you tell me what college this is, or what department of the college again? Give it to
College of Food, Agricultural, Natural Resources, Sciences. Took me like a year to remember that.
I can imagine it did, and then your title so long. So Peter is here as one of my guests, and the other one is Nathan, and we'll call him Nate, Benet. And Nate, you are a graduate student. What's your title?
I guess a graduate research assistant in conservation biology at the university.
And that's why you're here, because there's your professor, right?
Correct.
Everything you do is under his direction, is that correct?
Well, not everything.
Not everything?
I hope.
You hope. Okay, and now you actually came over here to the University of Minnesota. From what school were you in before? Where's your undergraduate?
For my undergraduate was University of Portland in Oregon.
And you did some studies there also on some of the things, because we're going to talk about common carp here in Rice Creek Watershed.
Right. So that's kind of initially how I got interested into fisheries. Is I did some salmonid habitat work out in the Mount Hood National Forest in Oregon. So, yeah, and eventually those studies kind of led me here.
Okay. Now, previously, when we were talking at the beginning, we were talking about the common carp, and Peter and I had done a show on the carp before, and now we're doing it on Rice Creek Watershed. And the reason why we're devoting ourselves to Rice Creek Watershed is because within this TV community, we have the Rice Creek Watershed, and we have a lot of carp. And since Nate is the one that Peter has evidently assigned to help study it, is that how it works? Or how did you do it, Peter? How do you get Nate involved in all this?
We kind of choose each other. He applies, and I say, oh, looks like a good guy. And then, of course, I knew he was. And yeah, it's not like, conscription or anything. He volunteered at that. After I made him an offer, and he accepted.
And how much time do you have to spend on this?
So I started in the fall of 2013, and we've wrapped up with field work probably up until this point, and so now it's putting it all together, and probably the spring of 2016 is when we'll anticipate wrapping up.
Well, we're going to be talking about the seasonal movements of carp, and we've decided, or at one time, somebody came to you. Did Rice Creek come to you? Did you come to Rice Creek? How was it that you decided to come to Rice Creek to do a study on the migration of carp through our system? How did that come about?
Well, I think Matt Koshin of the Watershed District came to Peter, who has worked with a number of watershed districts in the Twin Cities metro area, and they really wanted to really understand from a scientific perspective on how carp move throughout their system. So. Yeah, and that was honestly my task, is to figure that out for a couple of years, and we'll go through that today.
Okay, now we've got a slide here that we're going to start showing. In fact, a lot of the show right now will be involved with a lot of the slides that you've put together. And the first one we've got is on graphs and the details of the carp. And it's going to be showing more of what carp do. Can you explain how the carp are working within a lake? And the graph has something here we can show them too.
Sure. So carp are primarily bottom feeders, and they filter out what they want in the sediment, and in the process they filter out a lot of what they don't need, and that creates a lot of turbid conditions in the lakes in Minnesota, and in the process releases a lot of nutrients such as nitrogen and phosphorus, which are key nutrients that cause algae blooms in lakes, a lot of lakes here in the late summer. And as those blooms kind of proliferate, it just shades a lot of the sunlight that could potentially penetrate the lake and provide nutrients for the native aquatic plants that we like to keep around.
Mm-hmm.
So. And
a question, and it can be either one of you asked that could answer me on this one. Carp lay many, many eggs and spawn, right? Give me a little bit more about they're called ecosystem engineers is a term that you use. Tell me a little bit about that. What a carp.
So that term refers to any organism that basically remakes the ecosystem that it resides in. And I would suggest humans are definitely ecosystem engineers, the way we've changed our world. And carp do the same thing when they get into a system, as Nate mentioned. They basically dig it up, they release nutrients. What he didn't mention is in the process they also uproot a lot of plants, and then it no longer becomes suitable for plants, which, Nate went into some detail. So it becomes a self-perpetuating negative feedback system, and you have a turbid green lake that is basically forever going to be like that as long as the carp are there. So that's what an ecosystem engineer is.
All right. Now, you've done some work, and I suppose this is something more that you've done, Peter, and that was on that Purgatory Riley Watershed District. And give me something that you were doing then and how the carp was moving through that system.
Well, one of the, so this was sort of the precursor for Nate's work on a much smaller scale, but we wondered there basically why there were so many carp. Because you don't always see them everywhere. There were an awful lot, and all those systems were green, like many thousands of lakes in Minnesota are, frankly. And basically, we started radio tracking and following this fish just to see where they were, based on an Australian model, hoping to remove them. And then all of a sudden, my postdoc at the time realized that they were leaving the lakes entirely, and they were going somewhere else. In fact, they were moving through these little creeks. They were only open in the spring and disappearing, and most people didn't even know those creeks were there. And we followed them, and that's when we discovered they were moving to these side-lying marshes where they were spawning and having their young. And then we came up with a hypothesis that basically the reason there were so many was they were outsmarting everybody, and they were leaving the immediate vicinity every year to spawn in secret in these nursery lakes where no one else was. Often they're very degraded systems, highly nutrified, with no other fish or anything like that, and then they were finding their way back. So there was a cycle going on within lakes, leaving and coming back, and the whole watershed was involved, not just single lakes, because everyone had been focused on single lakes, not thinking about the watershed and adjoining lakes. So we wondered that they were outsmarting us and using the whole thing.
And when they're doing it, they're moving then, and the whole reason they're doing a lot of that moving is to go ahead and find someplace spawn, and they do it in the shallow areas and then come back. When did they return back to these dark areas, the deep areas?
Well, that actually, I'll let Nate talk to that, but that's one of the things he discovered, because we just found evidence for this in one very small watershed with 3 small lakes. We didn't understand the extent of these movements or the exact timing of it.
Okay. So, Nate, when you went to Rice Creek Watershed, we know that there's lots of interconnected shallow lakes.
Yes.
So give me a little bit about what you were doing in the Rice Creek Watershed now when you went there.
So the system before provided a good model of what a smaller system looks like, with a few main deeper lakes connected to one primary shallow lake. But the Rice Creek Watershed kind of takes that to another level. It's a much larger system. More lakes that are all interconnected, and predominantly one main deep lake that we centered on, Long Lake in New Brighton, as the winter refuge for the adult carp movement question. And we just asked the simple question: do carp perform seasonal migrations in larger interconnected systems? And that's really the basic question that kind of drove this whole study, and we'll see that play out in a moment.
Okay. Now, I understand the deeper lakes you call something that's more than 5 meters deep, which is how many? 5 times what? 30? I go yards.
5 times
so
3,
15 feet, 15 feet deep or something like that. Okay. Now, the Long Lake water winter site that we have, you radio tagged some carp at that point, didn't you? To see and to follow through. Tell me about tagging carp.
So in the fall, primarily, we went out electrofishing for adult carp, and we focused on Long Lake in New Brighton since it is one of those deeper, more stable lakes. It's approximately 20 feet deep, and we radio tagged over 50 adult carp in that lake in the fall, and followed them into the all year long, really. And then the springtime was really that key time where we wanted to see where they were heading. And it turns out a lot of them, the vast majority of them, ended up leaving Long Lake in the springtime.
So how far up did our Rice Creek Watershed District, the connected system, how far up did they actually move, and when did they return?
So it varied. The radio-tagged carp went anywhere from 6 miles upstream to over 15 miles upstream. We even had a few tagged at a smaller refuge lake near the outlet near the Mississippi River, and those carp migrated over 20 miles upstream to the shallow lakes and the Lino Lakes area. And they'll spend anywhere from a few weeks just during the spawning period in the spring to the majority of the summer in those shallow lakes before they return back to Long Lake for the winter.
Now carp, when they spawn, they lay how many eggs or how many a year? It's a huge amount.
They mature at several years of age, about that kind of size, a foot. And
okay.
They might have something like 1 million eggs, and by the time they're reach middle age, which for a carp is 30 or 40 years old,
No.
they live to be 60 or 70. Older than me. I'm still not as old as the oldest carp we've caught. They will be producing several million eggs every year.
When Nate went to one of my meetings on Rice Creek
Yes, I
Watershed,
know, yeah.
and you had a slide, I don't have one here, that showed how fast carp can grow.
Yes.
So tell me, they're these tiny little baby carp, and in a year, aren't they already huge?
In a productive system, they may be about 9 inches, something like 15 centimeters, which means that they're basically beyond predation pressure. So if you live to be 1 year old as a carp, you're probably good for another 40 or 50, pretty easy.
Because you've lived
around here in particular, because no one's fishing for them.
And we don't have a fish that's that large.
And we don't have a fish that's large or a bird that's that big.
Okay, now you did some radio tagging. You did it in the fall of 2013, and spring of 14, and the fall of 14. And these radio tagging that you did, it shows where you probably tagged some of them.
Right. So once we caught the fish that we wanted to tag, we did surgeries one by one, anesthetizing the fish, and then flipping them over on their belly, essentially. And right behind the pectoral fins, we made an incision to insert the radio tag.
How big is the tag?
So a tag's a couple inches long and about that big in diameter. So that goes inside under the muscle layer of the fish entirely, and the only component of the tag sticking out externally is a wire about 1 foot long.
A whole foot long?
Yes, and so you can barely even tell it's attached to the fish. It blends in quite well. And that's the external antenna that the transmitter sends radio waves to the receiver that I carry around in the field. So. And
then when you go and you've got them tagged, you can even follow them when it's wintertime, right?
Correct.
So you get this little wire that you've got a foot long. It can be picked up through ice, so you know where they are, even in the winter?
It can. So the signal gets a lot weaker as the ice gets deeper and deeper throughout the winter. So I have to get closer to the fish than I normally would have to in the summertime during open water periods. So typically in open water, you can hear the tags a quarter mile away. In the wintertime, you'll have to be within a couple 100 meters of the tag to pick it up.
Now, these fish don't get caught on something with this trail of a wire. You've never not had that happen.
I always ask the question, since sometimes the signal is really strong and very easy to hear, but as time goes on, you don't know what they hit, or something goes a little off with the tag, and you don't hear the signal as well. So you have to get even closer than you would normally have to. So there's little I don't know, nuances that you got to play around with.
The variations that can occur. I heard there was like 53 that you tagged, and you were able to keep following 52. And yet we know that a lot of people love to come to Rice Creek and either, do the spearing of them or something. Yeah. And if that happens and you got 52 back, we weren't really harming any of nobody caught them or speared them, and you were able to retrieve?
I don't think so. No,
you don't think so?
I was willing to take the chance, I guess. It's that's I guess a testament to say there are quite a lot of carp in this system that we're dealing with.
Yes, it is too.
And so that's why we're studying them before we hope to implement a management strategy for them.
And when you implant this, how large of a carp do you put the radio tag in? I mean, it can't be one of those 9-inch ones. You're going to do it in adult carp, correct?
Correct. Yeah, and that's what I studied specifically was adult carp. So they're anywhere from a couple feet long to over 3 feet.
And you said something about electronically catching them, or you do something
electrofishing.
Electrofishing. Is this to shock them in the water so that they're able to do it? I think I've seen films, and Peter may be even part of it. I think I've seen something where they actually jump up and they actually try to net them and put up on a boat that's got the electrofishing. Hasn't the DNR been doing something?
Oh, the DNR does a lot of that. We have one of these boats. It looks good, but I'll tell you, actually the boats are pretty ineffective, and that's an important point. The fields only go a few feet below the boat and maybe 10 feet out in front.
Oh, that's all.
So this is why nothing like this can even be used in a thoughtful manner to control carp, just to sample them. It's a pretty crude sampling technique. So.
Now, I'm going to jump off a little bit here from script in this fact that you, Peter, have been involved with putting in some sort of an electrical barrier. What is it, Lock and Dam 9 or something along the Mississippi River?
Well, actually, we've looked at that, but we're more interested in using sound systems.
Sound.
Because these carp have specialized ribs that connect their swim bladder with their inner ear. So they have an exceptionally sophisticated and sensitive sense of hearing, much more than native fish. So we believe, and this is a different issue a little bit, that we can use sound to safely and inexpensively repel a lot of these invasive carp at different places in the state that you couldn't do much else. So actually Rice Creek might be a candidate for something like that too.
Eventually.
Eventually, yeah.
And I know we're talking about the common carp.
Right.
I'm always involved or a little bit concerned about Asian, and I guess it should be the proper name. It's silver or bighead carp. But those are the ones that we're just trying to stop, isn't it, down
in
there
the
at the
Mississippi? And just jumping ahead, my goal is to do everything I can to prevent the Mississippi from becoming the carp heaven that Rice Creek Watershed is at the present time.
Yeah.
While there's still time.
Yeah. In fact, the Rice Creek, I've got fisher people and all in the family, and they have called this the most abundant place for carp that you could possibly get is in Rice Creek. And it causes us lots of problems from what you showed us at the beginning of how they can dig into the underground and bring up all of the phosphorus and start really disturbing plants and everything. But, okay, so we've also in January of 2015, they're in water that's is it less than 39 degrees in the ice in Long Lake, or what is it that they, in January 15, is that where they're found a lot in that time because the water's that cold and they like to go into Long Lake?
So they like going back to Long Lake because it has more oxygen than those shallow lakes in the Lino Lakes area. And that's just a matter of it's deeper, it's more stable. A bigger body of water creates those conditions that they can overwinter safely in.
It's their Florida.
That's right. So, and right below the surface is definitely the coldest water, right next to the ice. But it's also a depth that has the most oxygen for the carp as well. So. Typically they'll be hanging up near the surface, and once you find one of the radio-tagged carp in the winter, you usually find a lot of their friends as well. And that's what you see in this January 2015 picture is a rather big aggregation of radio-tagged carp all in one group.
Now, the slide we've got up there, you see sort of the thread going through. That's supposed to be Rice Creek?
Correct. It kind of comes into the lake and goes right out at the north end.
And so when they are going there in January, the January 14th, and you see the carp's down in that lower part of Long
Yes.
Lake. So Long Lake, that's the deepest area that you think about, the 20 feet down.
So that area in particular is definitely 20 feet, yeah. But they're probably, I don't know for sure, but they're probably within 10 feet of the surface.
And is this where we have in the past, Rice Creek's done some netting of them? Is that the area that they've been netting? Maybe, Peter, do you know exactly where we did some netting?
It's that general area, but I think Nate will point, I hope you'll point out in a second, they don't stay there. They're not sleeping or anything like that. They're pretty active and vigilant, actually.
Carp are smart, aren't
They're
they?
smart. They're schooling, and they're watching out for fishermen. And my suspicion, actually, is this is a relic behavior from their lives in the Caspian Sea 1,000 years ago, where there's things like seals, and they're maybe just watching out for
a seal to come
a seal
and
to
get
come by.
them.
Maybe, I don't know.
Because they've got that memory or
Yeah,
something
memory
built
and
in
the
that
sensitive
says
to
it.
sounds. You know, seals make sounds. And anyway, by grouping together like that, and they're probably not eating at this point, and they're certainly not spawning. Why would you do this? This is one of the big mysteries to us. But, you know, one reason would be if you were afraid of something, that's a good, like birds flock and
Sure,
so forth. You know,
protection.
you form a tight group.
Okay, now in February of 2015, they have moved on in another area,
Yeah.
and now they're gone to the upper part of Long Lake.
Correct. So they completely switched basins from the south basin to the north, and for the remainder of the winter, they predominantly remained in the north basin, and that shows the aggregations do move around at winter. You can't just target one specific area for a netting event in the winter, an under ice seining. You have to use these radio tags to really expose
where they are.
all the other carp are.
Okay, so in March of 2015, we have them moving again. And now what this is? This shows
So
our-
this is kind of a blown up view of the watershed kind of as a whole, that interconnected system. But it shows the very tight grouping of radio tags in Long Lake and New Brighton at the bottom left, and we'll see that really start to disperse once the ice comes off. Water temperatures warm up to between 40 degrees Fahrenheit to 50. The carp are the temperature of the water. And they'll recognize that and notice when it's time to move.
Oh, so in our April slide here,
Yep.
in April, then we get the water at that 50 degrees, and you said they stay basic because they're cold-blooded, so they're going to stay whatever temperature is, that water is, and they can tell, hey, I'm getting hot, I got to move out of here? Is that
Yeah,
it?
they've spent 3 months under the ice, and they're rearing to go when the springtime comes. And this slide really kind of just shows they take off very, very fast.
Wow, they
And,
must. Look at how they've all gone up there to
it was
shallow water.
In the year 2015, it was the very end of March, very beginning of April that they left Long Lake. And that was really only a few weeks after the ice left entirely.
That must be when everybody gets there to that one bridge we've got that's on County Road Highway 10, and it goes in there, and there's right there that narrowing too, which we'll get to, I'm sure, in a minute here, as to that's where you go out and start spearing them because they're headed out.
Yeah,
Holy cow.
the fishermen had to get there fast this year because they didn't wait around at that area this year at all. Last year, the flows coming under that culvert were very high, and they spent a few months just kind of stacked up right where the creek passed under the interstate and waiting for the opportunity to get through. So it was a lot of opportunities for them to go fishing for them while they were waiting for their chance to get through that culvert.
Well, if you're trying to stop the carp from moving, and you know they go up there to spawn up north in the Rice Creek chain lakes, is there some way that we can, kill them at the time that they're right there and really stop them, or What we don't know yet. You haven't got your study all done as to
Right.
what to do right at that point. Is that it? Because that sounds like the choke point.
Right, and we're looking for those choke points. Where are those areas where you have large numbers of carp that have to kind of funnel through this
Yes.
one area? The width of the creek is about as wide as your driveway.
Yeah.
So that they all have to go through that area, and you can see it's all directed upstream of Long Lake in one direction, and that's another area where we can really kind of target our management efforts.
Now in October we have another picture of Long Lake, and now we see that they have come back down to Long Lake after they've spawned. They're back down now. They
Right.
were all running upstream. Now they're back. We're
So-
going to get to winter.
Exactly. So the previous slide showed their distribution during the spawning season,
Yes.
which lakes they went to, and the vast majority of them returned to right where they started. So it shows they went from a refuge to a spawning lake where they also feed in the summertime, and then they return to the refuge lake. So of the 50 or so that went up, all but 3 of them came back. So you can see there's a few fish in George Watch. There's 1 fish in Rashino Lake. So they're probably going to ride out the winter in those lakes, and so they're taking a chance. It's not. There are times where those lakes, it's not the area to hang out in the wintertime, such as the 2013-2014 winter, which was very severe.
And we've got much warmer right now, too.
Right.
So now we go, and there's a couple pictures. There's a picture of that we know that they've been radio tagged, and then we've got one where they're by 35W, and there's a culvert under County Road 10, and then they spawn and return to the lake. So that'd be the next slide that we'd have, and I guess I'd tell there we go. We've got it right there. Now, on the right-hand side, the black is the creek.
Correct.
Okay, and that highway is 35?
35W.
Okay, and to the right would be what we call the TCAP property. I think it's going to be called
Yes.
Rice Creek Commons. And it's right in there, is that choke point?
Yep, that's where they all have to funnel through to get, and it's their migration corridor up to those shallow lakes to spawn. And of the 53 we had start in Long Lake, 52 of those 53 went right through that area. So if you have 52 radio tags going through, that means a lot of their other friends that aren't radio tagged are also going right through that area.
And of course, now on the left, what's that picture of?
So that's a picture of a winter seining that's done under the ice. And what this type of removal management strategy does is it uses radio tagged fish to kind of expose the locations of non-radio tagged fish. And in the wintertime, in January, February, March, you saw pictures of the radio tagged fish all grouped up into these very tight groupings. And those are the groupings that are targeted by those commercial fishermen.
And that is a commercial fisherman netting them right now in that picture on the left-hand side.
Correct. And the vast majority of that haul is a lot of adult carp.
Okay. Overall, what would your estimate be? I mean, how many carp? You tagged 52, 53, you find, and they returned. What do you think is the count of carp we might have in Rice Creek?
Well, I've done estimates just this fall, and we're still kind of running through those numbers. But they're very crude estimates, and in 20 minutes' time, we may catch 20 adult carp in Long Lake, and that gives an estimate that we can kind of extrapolate to what is the population in that lake. But we'll get a better estimate this winter with a group that's doing mark recapture studies. So they're fin clipping a lot of carp, hundreds of carp in Long Lake, and in the wintertime they hope to do some seining this winter, and they'll see how many of them in those seines are clipped, and they'll get a better idea of the actual population. And
well, fin clipping, does that prevent them from swimming properly or adequate? I mean, to me, if it's like taking an arm or something. Can they still fit? They go like this.
They'll still get to swim fair like normal. It's one of the pectoral fins right underneath, so it's hopefully minimal disturbance.
Well, I shouldn't worry about it. I want to have them eradicated.
And carp are pretty hardy to begin with.
So probably like a pinky.
Yeah.
Okay, Peter, so he's your graduate student and studying all this. What is it that you want to accomplish from this? I know you're learning and everything about carp and movement, but is it eventually so we can eradicate them all?
Eradicate? No. I'm more interested in seeing if we can develop sustainable control strategies that safely and effectively bring them to a level where they're not causing the whole scale and environmental rebuilding, engineering that they're capable of. The reason I'm saying eradicate just because it would be nice, but I think it's sort of unrealistic. And besides, we brought them here. They're our guests. So maybe just quite a few less than what we have at present. And I understand, Nate correctly didn't want to speculate on the numbers, but I'm sure he's marked less than 1%, less than 1/1000th. If this is like other systems, the levels of common carp in there are 3 or 4-fold higher than that lake should have if we were to allow if we wanted native vegetation to come back and that kind of thing. The interesting caveat about Rice Creek Watershed, though, is that they're using the whole extent of the watershed very effectively and sort of in a sequential fashion. So there probably are unusually high densities in Long Lake because they've all come back there, and yet they use the whole extent to feed. So it'll be interesting to see what the final number really is. Might be amazingly high in that particular lake in the winter months, and then when they're all spread out, more typical.
I know of people that live on Long Lake, and they've used it, and they use boating and everything like that. What type of damage are those carp? And I know we had the slide initially to say, but are we finding out in Long Lake, and you probably that hasn't been your focus, but what are we doing to it? We're taking out native vegetation, where they make the lake mucky. Isn't all these things going to happen with carp? They push out fish that you might want to catch. Is that all the types of things? What's all the damage carp cause?
Well, if you do go to Long Lake, you don't see a lot of aquatic vegetation to begin with. And carp need aquatic vegetation to spawn, and there's not a lot in Long Lake, and that's just one reason why they're likely going up to those shallow lakes to spawn, where there's abundant aquatic vegetation everywhere for those eggs to really adhere to.
What enemies do they have? I mean, I know we talked about when they get bigger, but the little babies, you said 1 million might be what a female can spawn, and fertilize or whatever has to be done. But the point is that they start out very small. What would be one kind of fish that they might want to eat? Or the fish
we can tell you, actually, and that's another reason to restore this lake, because the best reason maybe is that in the process of restoring and controlling carp, we could bring native fisheries back and put it back into balance. Because in other lakes we've looked at, the sunfish can really control carp. They can eat all the eggs. So if the native fisheries are truly in balance and healthy, then usually the number of young carp will be very, very small. So you get a double whammy. And what Nate also didn't mention is if you get the carp out, you'll see immediate improvements in water clarity and more plants, which not everybody likes, frankly. They've forgotten what plants are, but you get the plants coming back to where they were, maybe a century ago, what the lake should have. So anyway, it's a movement in the right direction. And once you get moving in that direction, it actually allows other efforts in lake restoration to occur, because it's pretty hard to do much if carp are digging everything up all the time, really.
Yeah, disturbing the ground underneath the water all the time. So Nate, what is your next step? Because I know you've done all this. Rice Creek Watershed has cooperated in helping out, and we've sort of been partners in this. So now what's the next step? Where we go from here?
Well, we really have to fit all of the pieces together of this puzzle. We've studied this adult carp movement for 2 years, and the watershed has studied carp movement within an isolated system. This shows movement in a larger interconnected system, and that's going to provide a lot of information on where to direct the actual management efforts. And there are 2 choke points that we really want to emphasize, is those winter aggregations and those migration routes where they're kind of funneled into these choke points. And where can you get the biggest kind of bang for your effort and to targeting management. And so those are kind of preliminary things that we're thinking about right now. But this long, cold winter ahead of us, that's my homework, is to put it all together and to be able to better guide the watershed and their efforts in the future.
And then the watershed will have that in their budget to
That's
try
right.
to see what we can do and where we can go from there. Is there grants that are able and possible in studying something like this?
Pretty limited, actually.
It is.
Yeah.
And yet we all complain about it, so
I
you would
know.
think there'd be some money that would be put forth
Well,
towards
we've
it.
been able to get some money at times, but it might be nice to partner with the watershed. That would be a possibility. With the LCCMR, perhaps.
Sure.
I don't know what to say. People, it would be nice if people were willing to kind of take a little bit more of a chance on some of these things, because these are very, very difficult problems, and we're all going to have to take a chance on it a little bit with some more research to figure it out, because I don't see much progress, real progress occurring if we don't understand the systems a bit better. So, yeah.
And that's the purpose of it. That's
the purpose
of a
of it all,
study
right?
and
Improve our
everything else.
lives and move ahead.
Absolutely. Well, Peter, I'm glad that you suggested to Nate, or however you two found each other, that he was going to go ahead and help pursue this. And I'm glad Rice Creek Watershed was able to participate in some of it in the future. So we have that partnership. And yeah, I
been
hope
really
that
great.
we do it. See where it goes from here.
Learned a lot. A lot of people will benefit.
Yes,
and
it
a
will,
lot of
because
fisheries and a lot of watersheds.
and this will come out as a study with a paper
yeah.
written so that we can
couple
all
papers,
see
I
what's
hope.
happening. Again, since we all know that we all say carp is one of our things that we want to get rid of because it's ruining our ecosystem of what we feel we want to do in Minnesota, heck, nothing better than having a good fishing area
Right.
and of the kind of fish you want rather than carp.
Right.
But
Exactly.
otherwise, I think you mentioned you have some carp recipes. A person
I
could
do.
eat them.
I do. I can get them.
You can get them, huh?
Oh, yeah,
Well,
yeah.
don't send them to me, okay?
Oh. They're pretty good.
They're pretty good.
The part of the problem with the carp has been no one's really given them the respect they need, either or deserve, either frankly as just a species or to eat. Because if you treat them right and you cook them fresh like you would a walleye, they taste a lot better. And that's been one of the major problems. People treat them like junk fish, and they
Bottom feeders.
bottom feeders, and then they don't refrigerate them or whatever. And by the time you cook it up, it tastes like, and that's because you treat them like So that's what happens.
Well, we will look at this because sometimes they're treated as enemy, otherwise you can treat them better.
Yeah.
But thank you so much for both of you to come in. Thank you,
welcome.
Nate
You're welcome.
Benet and Peter Sorensen.
Well, thank you very much. It's been a real
Appreciate your
pleasure.
visiting with us, and I hope that it's something that gets everybody fired up about doing something.
Oh, it
to help
should.
us.
There are ways forward, see?
Yeah. Thank you very much
Thank
for
you.
coming.
Thank you,
Thanks.
Barb.
Thank you. And thank you, everyone. Appreciated your watching.